Elon Musk's SpaceX expects to lose nearly an entire launch's worth of Starlink satellites after a storm created by the sun struck the Earth's atmosphere. The company launched 49 Starlink satellites with the Falcon 9 rocket on February 3rd. The mission was successful in delivering the batch of satellites to orbit, but disaster struck the next day. How can this affect the service being provided by SpaceX's Starlink satellites? What plans does Elon Musk have to recover from this disaster? Up to 40 of the 49 small satellites launched have either re-entered the atmosphere and burned up, or are on the verge of doing so. The company said in an online update. SpaceX said a geomagnetic storm last Friday made the atmosphere denser, which increased the drag on the Starlink satellites, effectively dooming them. Ground controllers tried to save the compact, flat-panel satellites by putting them into a type of hibernation and flying them in a way to minimize drag, but the atmospheric pull was too great, and the satellites failed to awaken and climb to a higher, more stable orbit. According to the company, SpaceX still has close to 2,000 Starlink satellites orbiting Earth and providing internet service to remote corners of the world. They circle the globe more than 340 miles up, 550 kilometers. The satellites hit by the solar storm were in a temporary position. SpaceX deliberately launches them into this unusually low orbit so that any duds can quickly re-enter the atmosphere and pose no threat to other spacecraft. There is no danger from these newly falling satellites, either in orbit or on the ground, according to the company. Each satellite weighs less than 575 pounds, and SpaceX described the lost satellites as a unique situation. Such geomagnetic storms are caused by intense solar activity like flares, which can send streams of plasma from the sun's corona hurtling out into space and towards Earth. Since launching the first Starlink satellites in 2019, Elon Musk envisions a constellation of thousands more satellites to increase internet service. SpaceX is trying to help restore internet service to Tonga through this network, following the devastating volcanic eruption and tsunami. Starlink is the company's plan to build an interconnected network with thousands of satellites to deliver high-speed internet anywhere on the planet. SpaceX has launched about 1,900 Starlink satellites to orbit to date, which has around 145,000 users of the service. Timothy Skov, a research scientist of the Aerospace Corporation, broke down the basics of a geomagnetic storm for CNBC. First, the sun shoots off magnets in the form of a storm. The Earth's magnetic shield dumps the solar storm's energy into our planet's upper atmosphere and heats it up, causing it to inflate and become denser. This increases the drag on satellites in low Earth orbit. SpaceX said that escalation speed and severity of the storm caused atmospheric drag to increase, as much as 50% more than the satellites typically experience in low orbit. After the increased atmospheric drag was detected, the company's operations team put the satellites into a fail-safe mode that rotates the spacecraft onto its edge to reduce drag, a position the company has previously described as a shark fin orientation. About 10 of the Starlink satellites are expected to survive and climb to their intended destination orbit. SpaceX did not indicate whether it was aware of the storm, which the National Oceanic and Atmospheric Administration says was generated by a solar flare on January 29th. NOAA measures geomagnetic storms on an increasing severity scale of G1 to G5. The agency had issued a warning for a likely geomagnetic storm of G1 to G2 on February 2nd, the day before SpaceX launched. There are an average of 1,700 such G1 storms over the course of an 11-year-long solar cycle, according to NOAA data, highlighted by Erica Palmiero, a space weather research scientist at Predictive Science, a company that supports solar studies for U.S. government agencies. It's a quite common situation, in terms of geomagnetic activity, to see a storm the strength of the one that knocked out the Starlink satellites last week, Palmiero said. SpaceX deploys the satellites in a lower orbit initially to both launch more at a time and so that any issues identified after launch will result in a malfunctioning satellite quickly deorbiting and burning up in the atmosphere. The company advertises its Starlink satellites as designed to fully disintegrate when re-entering, meaning no orbital debris is created and no satellite parts hit the ground. London-based OneWeb has its own internet satellites up there, and Amazon plans to start launching its satellites later this year. Astronomers are distressed that these mega constellations will ruin nighttime observations from Earth. The International Astronomical Union is forming a new center for the protection of dark skies. What the loss means for SpaceX. As a private company, SpaceX does not disclose the exact cost of its Starlink satellites or its Falcon 9 launches, but losing the majority of the mission could be a financial hit upward of $50 million. And for the satellites, the company's leadership has said that an estimate of $1 million cost per spacecraft was way off. At half that estimate, or $500,000 per satellite, the loss of about 40 satellites would be worth around $20 million. Notably, SpaceX has previously deorbited 1 or 2 Starlink satellites after a mission. Astrophysicist Jonathan McDowell explained. McDowell is an astrophysicist at the Harvard-Smithsonian Center for Astrophysics and cataloged satellite launches. But to lose most of the batch is unheard of, McDowell said. This is huge compared to anything that's happened before. McDowell also said the loss is significant for SpaceX as, in the context of historic satellite launches, the company has been pretty successful. The rocket at least is really reliable, and since mid-2020, there have been relatively few total failures of Starlink satellites, McDowell said. More storms coming. While this event essentially boils down to unfortunate timing, that doesn't mean that space weather doesn't pose a risk to technology in space. Space weather affects satellites in different ways. We can have energetic particles that will penetrate the satellite and cause single event upsets or single event effects. Or it can create a charging environment, or a static discharge can occur, and that can be very problematic to satellites. And these risks could grow in the next few years as we approach the next solar maximum, or period of greatest solar activity during a solar cycle. It's been very quiet for the last 2 or 3 years, but over the last year, we're starting to ramp up down to the next maximum. The solar maximum is expected in 2025, so we're seeing increased space weather activity. Bill Murtaugh, the program coordinator at NOAA's National Oceanic and Atmospheric Administration Space Weather Prediction Center said, but with this expected increased solar activity, Murtaugh's team is working with aviation satellites and earthbound technology like power grids to help them in their preparation. Murtaugh did note that none of SpaceX's Starlink satellites that were already in orbit, there's more than 1,800 of them, or any other satellites for that matter, were affected by Friday's geomagnetic storm event. SpaceX's Starlink satellites typically orbit Earth at an altitude of about 340 miles, 550 kilometers. The 40 satellites struck by Friday's geomagnetic storm were much lower, flying as low as 130 miles, 210 kilometers, in an initial deployment orbit before they had a chance to reach their final altitude, SpaceX has said. Geomagnetic storms explained. Geomagnetic storms are magnetic disturbances in Earth's magnetosphere caused by energetic charged particles emanating from the sun, known as the solar wind. While our magnetosphere, the system of magnetic fields that surround Earth, deflects most of these particles, some get through. These storms can be mild and create beautiful auroras in the sky, but they can also interfere with our technology in serious ways. The recent particular storm follows some disruptive activity on the sun at the very end of January, Murtaugh said, adding that this activity produced a coronal mass ejection, CME, or powerful eruptions on the sun's surface that spew solar material outwards. CMEs can be seen as essentially a magnet that was shot out into space by the sun, and during a geomagnetic storm, that material is going to couple with Earth's magnetic fields. It is known that solar activity and such storms pose some level of risk of interfering with earthly technologies like satellites, but as Murtaugh noted, while teams at places like NASA and NOAA continuously monitor solar weather and activity, there is still a level of unpredictability. The geomagnetic storm is such a complicated process because the eruption occurs on the sun 93 million miles away, Murtaugh said. There are times when we can be surprised when we see a coronal mass ejection that we might think would miss us, but it hits us and vice versa. Let us know what you think by leaving a comment in the section below. Thanks.